Dear students, today we'll start with digital communication techniques, in which we'll see the first part, what is a signal and what are the classifications of signals. So the topic will be signal and its classification. Now, basically, what is a signal? Signal is something which carries information. Signal is something which carries information. And it can carry information and occur everywhere. Signals can be in the form of electrical, can be in the form of acoustic, can be in the form of video, can be in the form of biological, can be in the form of informational, anything. A signal is one which carry information is our basic statement. Now here we are going to see what is a signal, define a signal, and then what are its classification. So if you go to define a signal in a simple language, you can say a signal is an electric current or electromagnetic field. Okay, because electric current means it can pass through wires. Electromagnetic field means it can transmit through air without any wires or without any medium. So a signal is an electric current or electromagnetic field which used to convey data. So it is used to convey data, that is transfer data, or a data itself, that is information or message, from one place to another. So signal is an electric current or electromagnetic field used to convey data or information from one place to another. Signals basically are functions which carry information. Signals can be described mathematically also. Say, for example, in mathematics, signal S we can write as S is equal to function of time. S is equal to function of time. So in this way, mathematical analysis also can be done. And electrically, a signal can also be represented like this, okay, or like this, okay, or like this, sawtooth, anything, any type of signal can be represented. Now, signal is something which is a waveform or which is a function which is going to carry information. It is different from noise. Noise is unwanted thing, but signal is a desired thing. Signal is a thing which conveys information. It is an electric current or electromagnetic field which is used to convey data or information from one place to another. Now, after knowing this basic thing about a signal, we'll go to see the classification of signals. So if you see here, we have done 7 ways of classification. So 7 types of a classification of signals are shown. Number one is a continuous time CT and discrete time DT signals. Second one is also on the same lines, analog and digital signals. Third one is real and complex signals. Fourth one is a deterministic and random signals. Fifth one is even and odd signals. Sixth one is periodic and non-periodic or aperiodic signals. And seventh one is energy and power signals. So let's see the first one, are continuous and discrete time signals. Now here if you see a continuous and discrete time. In a continuous, it is a signal to be continuous when it is defined for all instants of time. So here if you see, it is defined. Now say this is your x-axis for time. So all instants of time, you take any time, the signal is defined. You take any time, the signal is defined. You take any time, the signal is defined. So it is a continuous signal. This is continuous signal which is defined for all instant of time. You take any time, you take this time, it is having certain value. You take this time, it is having certain value. You take this time, it is having certain value. Okay, like that. When a signal is said to be continuous, when it is defined for all instants of time, that is called as continuous signal. Similarly, if you come to see what is discrete signal here below, a signal is said to be discrete when it is defined at only discrete instant of time. Means at various instant of time, a separate instance of time. That means, say if you start from here, at this instant of time, the value of signal is this. At this instant of time, the value of signal is this. At this instant of time, the value of signal is this. At this instant of time, the value of signal is this. But in between here, or here, or here, or here, you don't have any values of signal. Okay, so it is at different time. It is at separate time. So a signal is said to be discrete when it is defined at only discrete instance of time. Okay, so this is the difference between your continuous and discrete time signals. And now we'll go to the second one, analog and digital signals. So analog and digital signals are on the same lines as we have studied our continuous time and discrete time signals. Now here we can define analog signal as analog signal is one in which both amplitude and time vary continuously over their respective intervals. Say on top, this is the first figure you are shown the analog signal, and this is your axis of time. Okay, so both time and amplitude. So this is the amplitude which is varying according to the time. Time is also varying. Okay, time is also varying. Amplitude also is varying. Okay, so the value of amplitude also is varying. Time also is varying continuously over their respective intervals. So this kind of signal is called as analog signal. Similarly, when you go to see a digital signal here, in a digital signal, both amplitude and time are taken at discrete values. Both amplitude and time are taken at discrete values. Okay, so this is called as digital signal. So this is the difference between analog and digital signals. Then we'll go to see what are real and complex signals. Real signal xt is a real signal if its value is a real number. Or if you go to see what is complex signal, a signal xt is a complex signal if its value is a complex number. It is not a real, it is real plus imaginary, it is complex number. So if you are having real plus imaginary, it is a complex number. If you are having only a number, real number, then it is real number. So if the amplitude or if the signal value is real in terms of numbers, if it is a real number, then it is a real signal. And if the value of amplitude is in complex form, then it is a complex signal. Then we'll go to see fourth one, deterministic and random signals. Deterministic signals are those signals whose values are completely specified for any given time. For any given time, if you want the value of the signal, the amplitude you will get. Say for example, this is the time, and if you just go like this at any given time, say this is the time, you will get a value, a specified value. If this is the time, you will get a specified value. So deterministic signals are those signals whose values are completely specified for any given time. Then what are random signals? Random signals are those signals that take random values at any given time. It takes any random. It is not giving you any fixed value or any specific value. It is going to give you random values. So random signals are those signals that take random values at any given time. Then we'll go to see even and odd signals. So what are even signals and what are odd signals? Okay. So here a signal is said to be even when it satisfies the condition. Okay. When it satisfies the a condition. Say if I write a condition here, if it satisfies the condition x function of t is equal to x minus t. That is, we have written here for even. So this is x t, say this will be x minus t. Okay, if these both are equal, then it is called as even signal. Okay, similarly, when the satisfying condition is x of t is equal to minus x of minus t. Okay, that means here you can see this is x of t, and this is, both are having, this is minus, this is also minus, so the quadrant itself is having both the axes as minus. Then here you can see xt is equal to minus x minus t. Okay, if this is the signal, then it is odd signal. So if the signal satisfies the condition xt is equal to x of minus t, then it is even signal. If the signal satisfies the condition xt is equal to minus x of minus t, then it is odd signal. Okay. Then we'll go to the next one. What are periodic and non-periodic signal? Okay. So here we have shown on top what is periodic and below what is non-periodic. A signal is said to be periodic if it repeats at regular time. So here you can see you have shown time. Here you can see this is a time period. Okay, even you can take this as a time period till from here till here. Okay, so this also you can take as time period t naught. You can take from here till the end. This also has a time period of t naught. So if the time period is at regular intervals, if it is same, then it is called as periodic signal. Similarly, if you see the second wave, non-periodic signal or aperiodic signal. Non-periodic signal do not repeat at regular time intervals. The time intervals can be anything. So here if you see, if you're going to start from here, the first one you can take from here till here. This is your one time period. Okay, and from here till here, this can be your second time period. So these time periods are different. Time periods are different. So they do not repeat at regular time intervals. So they are called as non-periodic signal or aperiodic signal. Okay. The next we'll go to see what are energy and power signals. So here you can see energy signals are defined as total energy E of a signal xt can be defined as E is equal to integration of minus infinity to plus infinity. Okay, then the signal square, that is x of t square, and you are integrating it with respect to t, that is dt. If this is the equation, okay, this is the equation, so it is giving you the total energy of xt. Okay, now once you have got the total energy of xt, okay, this signal xt is an energy signal. Okay, this signal xt is an energy signal if and only if the total energy of the signal satisfies the condition 0 less than energy E less than infinity. Okay. Similarly, if you see power signals, the average power P of a signal, the average power P of a signal xt is defined as, now here we have shown the equation here. So Pf is equal to limits t tends to infinity 1 upon t integration of minus t by 2 to plus t by 2 xt whole square with respect to t you are going to dt. So with respect to t you are going to integrate. So this will give you the average power. The signal xt is a power signal if and only if the average power of the signal satisfies the condition 0 less than p and less than infinity. Okay. Now these are your after analysis, whatever conclusion you have got and whatever formula you have got for energy signals and power signals. Okay. So the first formula gives you the total energy of a signal, and the second formula gives you the average power P of a signal. Okay. So with this, students, we end the types of signal. So first we had defined a signal, what is a signal, and then we saw what were the classification of signals. Okay. Thank you, students.